Hello, greetings. Welcome back to the best afternoon coffee time, an exciting topic at Solreg. We are delighted that you are here, so hold on tight, because today, after presenting our new Fast Flat in the online seminar 3 weeks ago, we have exclusively for you the online planning with the Solar.Pro.Tool, which will help you streamline your solar energy projects efficiently and effectively. That means, how can I plan the Fast Flat in such a way that I, as the planner or the one designing the system, am completely and totally sure of its accuracy and effectiveness. So we do not just want to give them a piece of iron or plastic or any other material. Mostly it is made of stainless steel and aluminum, but we also want to give them the security and assurance that when they carry out the planning, they may not have to know and understand all the various steps and details so precisely, but the system intuitively guides them through the planning process, through each planning step, so that they, as the one then responsible, are the one who can simply and effectively accomplish it perfectly without any difficulties or errors. For individuals who are not yet acquainted with the Speedy Flat, I have an online seminar accessible for them, which they can view at a later time. Let's swiftly switch to my screen. I will demonstrate to you how to navigate there, how to locate everything, particularly on our website under Company Hermine. I hope I clicked correctly this time. No, that was of course wrong again. Find company webinars here, the previous online webinars or online seminars, however you prefer to call them. Fast Flat System, the new flat roof system, as well as the new facade system, the SL Energy Wall, and a wide range of previous online seminars. For individuals who are joining us for the first time today, please feel free to click in and take a look at the flat roof system. Yes, for individuals who are not acquainted with it in any way, we will provide a very brief demonstration to them. And it appears in this manner, indicating that this system is composed of a few different parts, specifically 2 base shoes, one of which is large and the other is small. These base shoes also serve the purpose of functioning as the connectors for the system. This indicates that you have a broad support surface here measuring 200 x 200. For those who are unable to get enough, visit Intersolar at booth A240. Everything is fully set up there. Additionally, there are 2 extra components, namely 2 base shoes, available for your convenience. In addition, there are also spaces available for a variety of use cases, such as the creation of maintenance aisles specifically for east-west systems, providing enhanced accessibility and convenience. Located at the highest point of the ridge, as clearly visible in the background, it indicates the presence of a gap at this particular spot. This is the Generation 1 system, but easy for them to understand that there are also distances. In terms of design, this system is primarily focused on maximizing the installation of kilowatts in a given area, allowing you to make the most of the available space. If you desire maintenance walks, feel free to incorporate them and request a brief demonstration of the process once again. This is the base rail with one of the ground shoes that I already have attached. I clicked that on earlier. The base rail, along with the upper bracket, has the ability to tilt at a 10-degree angle for folding up, providing 2 positions on the top surface where you can either place the clamps or where they can be placed. Let us remain courteous. This means we have the opportunity to build with this east-west rail, east-west, in the corner clamp, in the quarter point clamp, to build a south system in the quarter point clamp, and also in the corner point clamp. This is very, very important. A question, Mike Kaufman. Will the old system remain, or is it being phased out? No, it will continue to exist because there are always situations where a flexible system is needed to be able to respond to different circumstances. This means being able to adjust the holders at the top and the maintenance walks flexibly. The old system remains in place. Furthermore, here too, a gimmick is added to the Solar.Pro.Tool. I will now mention the keywords ground pressure and soft roof membrane. We will talk about them shortly. The system is designed in such a way that a successor is then positioned at this location, which is a ground shoe. This one is mandatory and needs to be clicked into the system here, otherwise I will have mounted it incorrectly. Clicked into the system here, and then the next rail or an intermediate connector or comes here, as per the established procedure for proper installation and alignment. South system interesting. Here at the back, we have 2 wind deflector plates. One is the light wind deflector plate, mounted at the back here, and secondly, the standard wind deflector plate from Generation 2, aerodynamically optimized at a 60-degree angle for minimal ballast. A really great feature, in my opinion. I don't know, could you switch the camera for a moment so that it's easier to see? A really great feature, in my opinion, is that we can attach additional ground shoes underneath here. That means we now have the choice to manually select our footwear for the floor, either small or large in size, as we will see in a short while. And we have the opportunity to manually select the desired number of ground shoes we would like to place underneath here. Do I want to be on a first, second, or third layer here? Or am I on a very soft roof with a pressure-sensitive insulation where I need to be careful not to damage the insulation, rather not to compromise the insulation value, and can therefore automatically determine with the Solar.Pro.Tool's automatic surface pressure load calculation how many ground shoes I need, where and when, whether I need the small ones, the large ones, and also if I need more in terms of quantity, for example. Please provide guidance on the appropriate layer and type of ground shoes for optimal insulation protection. Whether there is a ballast tray on top of it or ballast brackets, and thus I have to add more ballast and all these gimmicks. So you see, it's incredibly easy. Anyone can put it together on their own, and as simple as it is to assemble, trust me, we can all do it here, just like we are in this online seminar. As easy as it is to assemble, it is equally easy to plan, and let's examine that together now. Yes, Solar.Pro.Tool. I believe it is evident to all that we possess a location in this place. I have already pre-designed the roof, and I will show it to you very briefly so that you have an idea of what to expect when it's completed. Please feel free to utilize the chat function. It would be highly appreciated if you could kindly include comments for me. This will enable me to assess the response to the system in this context. And prior to commencing, Mike Kaufman, various module dimensions within the Solar.Pro.Tool, you have the ability to design module sizes ranging from 1 M11 to 1.145, indicating that we have a relatively fixed width for the fast flat system. In terms of length, we have flexibility, allowing for planning starting from 1.72 meters per module and extending up to 2.50 meter or any other dimensions that may be required. It is important to note that currently, module manufacturers have agreed on an M13.4 as the standard module size. That was the case last year. Who knows what they will do next year? The whole situation can of course change again, and we may need to make adjustments. So, the important thing is, we want to provide you with maximum flexibility regarding the ideal clamping point of a PV module, and that is very important to me. Whether you have a smaller module now, are repowering, or whatever your plans may be, feel free to approach us. How can we assist you in this regard? It is relatively uncomplicated. If we have knowledge of the module, then we can also determine the appropriate choice for them, whether it is Generation 2 or the recently introduced Fast Flat. Affirmative. I'll quickly jump onto the roof that I've prepared. Those who have been here today have already seen that we have a flat roof with a 1-degree slope. For those who are now wondering, how far can I use it? System is up to 5 degrees. It's crucial. Here I've auto-detected interfering objects. I save the roof. Now let's start by selecting a membrane roof, bitumen, or gravel roof. As usual, I still need to correct the roof slope to 1 degree. I just noticed that I made a mistake. I hope the Solar.Pro.Tool won't cause me any trouble now. I will simply choose the SL Fast Flat South now. Here in the identical drop-down menu, we have the option to select the Fast Flat East-West or the well-known Generation 2 system in the South and West variations. Start with South, define snow load. Snow load Zone 2, calculate everything. Snow reduction, leave min. Service life at 25 YRs. Save. Click floppy disk icon. Move on wind load calculation. Wind load Zone 1. Terrain Category 3. Just select now. Need to think more about it. Consider carefully. For now, it is relatively easy to implement. Again, I will stick with a system service life of 25 years. Save the whole thing. Our roof is defined, and we can now save the roof. Choose our photovoltaic module, or I think I already did that earlier. Now in this case, it's a standard module, a 420W module. Click Save again, then go to the Construction tab. So far, we've only made minor changes, and now, very, very important. We have now presented a drawing here, and this drawing has the ability to naturally change as many times as necessary because we have a ground shoe present in this location. Here we have a ground shoe, These are our standard connectors. Here we have the spacer inside with a length of 445. By the way, if you change the wind deflector plate to the light version, you can also set the maintenance aisle to 700 here. Just some information for you. We have three options, 225, 445 and 700, with the 445 and 700 being for the south system in terms of distance. The 225 at that time, that is when we can have a discussion about the east-west system. Sebastian, greetings to you. The system, I assume, is able to be planned within the next 2 weeks. What you see here is still in my development version, but it is close, I would say. In reality, it still has some small errors and quirks, and then it will be freely accessible to anyone who is using our version. It is very important to mention that everything you see here is pre-assembled. That means the base rail is pre-assembled, this spacer is pre-assembled, these connectors. Maybe let's briefly go back to the camera. You don't need to measure anything on the roof anymore. Just lay out components and connect them at fixed measurements, fixed measurements, fixed measurements. Then here comes the connector or connectors also with fixed dimensions. You don't have to think anymore. You don't have to measure anymore. I'm saying it's that simple, but you have the option to align a rail once. On the roof, it goes quickly through, and you have it really easy. And that's why the name is fast and not long or slow or who knows what. Could have been, but it just isn't. This is of utmost importance. The drawing you are currently observing is not the actual representation of how it is intended to be installed on the roof. Here's a reminder for you, and in the report, you can find this calculation or the positioning of the ground shoes in the CAD plan. Why? I will show you that shortly. Now, I simply go back to 445 as the distance for the south system. They clamp them for us, self-explanatory, they know them. So in this case, we have the distance, a motion factor, and a wind deflector plate light as key components. I desire the lightning current resistant option. For those who wish to install the module in the quarter point clamp, please check the box provided. In my opinion, the clamping of the quarter point is self-explanatory. You just need to take a quick example. Where can we find it? Let's take a quick look and see. Our PV module, symbolically shown. In the background, you can see corner clamps. The clamps are here. For those who want a quarter point clamping, the clamp is placed in the quarter point here. Very important, when a quarter point is built, a stiffening plate is added behind it. This will be explained in a timely manner in the assembly instructions, installation manual, and assembly video to be self-explanatory and understandable for you, but simply to explain what is a quarter point clamping, how does it work. So, I will proceed without the quarter point clamp, lightning current resistant design. Can we check off cable management or not? That will be our cable bracket, no longer the cable clip. And here, I would like to have the automatic calculation of the ground shoes, meaning I now release the system. Please calculate the number of ground shoes under the base rails according to your ballasting of the module clamp, as well as the maximum compressive strength of the insulation. And now, of course, it's very important. Where do they get the data from? I have prepared this once. I'll show you this very briefly. This is now here, for example, at Rockwool. Rockwool says 20x 20 cm plate, which we meet with our standard ground shoe, with the large ground shoe. This implies that solely the big ground shoe can be utilized for this roof, and in case we return once more, for instance, it informs us. Now here is the manufacturer for the product Solar.Pro.Tool, which I find pretty cool in terms of the name. Can you use this value in kN per square meter for the point load of 20 by 20 cm? And when it comes to hard rock, there are various sub-levels. We are currently at a load of 40 kilonewtons per square meter with Durarock and so on. We completely eliminate the possibility of point load. This implies that we should consider it as a highly pressure-sensitive insulation material. What about them? They must gather data from the roof manufacturer, the hall builder, etc., so they know, yes, What am I allowed to do? What do I have on the roof? Do I have rock wool or knauf or who knows? That's important in this case. I take one step further in the planning. You remember the 40 kilonewtons and simply enter them into the system, the 40, and press save. Before pressing save, I will show you one more point. You can observe a clear expansion of the module field below, indicating that with this system, it is possible to have an area of 30 by 30 meters, and the spacing of the roof is naturally determined by the interior layout. That indicates we have enlarged the module area, or the area that can be constructed continuously and extensively, which means it should be feasible for them if they do not have maintenance aisles or similar requirements for access and upkeep. It is up to them whether they choose to install photovoltaic panels on a maximum of one roof to simply generate the maximum output of power here. Now, it's vital the roof isn't always flat. So if that means 1 degree slope, so a flat roof can also have a small ridge, a small eave, 1 degree up, 1 degree down would be 2 degrees. I still need to examine it more. Can I build on it, or do I need separation? This is very important to me. And now I have told them we have entered the ground pressure of 40 kN and are automatically calculating the number of ground shoes. Now, it's really important that you keep in mind, well, at which location am I? The snow also increases the pressure on the entire structure and has an impact on the load-bearing capacity of the substructure. That means if I'm with rock ball, with this gear rock or whatever it's called, or hard rock or I don't know, if I'm in, for example, Düsseldorf, I can build without any issues. Maybe in Rosenheim, it might be problematic again because I'm getting too heavy loads here. I just want to pass that on to you. Let's now look at the layout and examine the south system. The roof is wonderfully fully occupied. That's great. Of course, many obstructions, a lot of shade. What's important is that everything is now lined up with the designated spacer that we have entered. The list of parts has already been calculated. I will now simply extract a few modules here because it is too fragmented to show all of them. I just want to occupy the left module field for now and jump into the statics. In structural analysis, we'll see here we have a short loading time. There'll be optimization, I can already say. In the statics, we will again see our surface pressure weight or our ballasting, which is always an indicator of aerodynamics in the system. And if we just take a look in here now, as you were used to, it's relatively easy to recognize a ballast tray with 2 stones or ballast brackets. They are no longer a ballast tray now, ballast brackets with 6 stones. And here we see below the ground shoes, the system has now placed 3 ground shoes for us. Now let's proceed. Maybe we'll come across another spot where only 2 are already in place. With the east-west system, it becomes clearer and easier. I'm right there with you. I'll just quickly go through it. In this particular case, it is designed quite evenly and exhibits a high degree of homogeneity, and that's what I meant. Here you now have the option of ground shoe, base rail, ground shoe, base rail, the intermediate spacer, and then it continues again with the next ground shoe. So here it is designed quite homogeneously. Other topics like output, etc., like the structural report I've already generated earlier, which I'll show you shortly. They're similar to what you're familiar with. It is important that the component designations change: FLA bar, load angle, fast flat basic frame, a module, that is our basic frame, which I just showed you. Then the quick flat base plate, the ground shoe with 200x200, the quick flat ballast clamp. This clamp ensures the ballast angle is secured and prevents slipping. Here you can also choose between ballast clamp and universal clamp, which you are familiar with from generation 2. Also, there's the fast flat wind deflector light, meaning wind deflector plate in light version, lightning protection clamp on top, and our clamps. As always, you have the option to determine whether you would like to make alterations or include, enhance, or adjust the elements. I will quickly return to the CAD plan for a moment. I also want to briefly demonstrate that and provide a brief overview of its key features. And in the CAD plan, it actually becomes extremely simple now, because I have to say honestly, there is nothing more to add. Where there were dimensions before, where we talked about distances, where we discussed gaps, well, that's in the past. Now we can simply build one shoe, build the base rail, build the next shoe, build the base rail, and so on. So this is now assembly line work. You will see, this is the fastest, most quickly installable system on the market, combined with a lot of variables, using the same components they have in stock. That's always the exciting and beautiful part. Clamp is same, end clamp, middle clamp, lightning protection clamp, all same, only system better, faster, with less space. You will see clear added value here. You will notice it even during the initial planning. Looking back, I want to demonstrate it in the east-west during the planning. I go back to the roof side, select here easily, and set up the south system almost flat east-west. Save it. The steps are familiar. I accept any PV module, regardless of what it may be, proceed to the construction phase, and now I have the chance here to revisit and analyze the basic space structure using this drawing once more. In the basic frame or structure, this middle floor is not included. We'll also adjust the drawings for you so that it's easily understandable in the report. And here we now have the option to install a ridge adapter at the top with 225 or a maintenance aisle at the bottom. However, one thing they must consider is that when they set these gears, they'll be set globally. That means in this case we do not have a variable setting to adjust the module fields differently. The module array remains the same, parallel to the roof edge, or can be rotated to adjust the arrangement. Friction coefficient continues to be an essential and important element in combination with building height, location, wind load, and other relevant factors. You need to know what the coefficient of friction of your roof skin is. In this regard, it is naturally important that this is taken into account in our system. Feel free to talk to us about this. We also have friction values or friction test kits in our portfolio. Basic. Every company should have one to test when the time comes. Let's not deceive ourselves. The roof in the background here is beautiful. But we don't know if there's a building up front casting a shadow. Then you have moss here. Then the friction coefficient is different, like on a roof in a different place, at another location, or with a different roof structure, bitumen or foil or something else. Testing this will cost you very little money, but it also demonstrates how professional you are as an installer, dealer, or partner of ours when you enter a sales conversation and can say, look, this is the fact, that's why I need more ballast or less, etc. These topics are essential for you in the sales conversation. Here there's an option to activate quarter point clamping, lightning current capacity yes, no. I would like to use the universal clamp here to secure the ballast angle, and please provide me with cable management. Here also, now there's the choice. Let's proceed to the installation. Let's observe what occurs. I am going at a speed of 35 knots, or if you prefer, I am taking out the automatic button. You can determine the number of ground shoes you want to utilize, but I will inform you at this moment, I solely employ automatic since I prefer that. The system computes it exceptionally well. And then, of course, which module surfaces can be accessed, what is the distance to the edge, and what stone weight measurement would you like to have. You have the power to decide, not us. You can make the decision. So here I go with the 5 kilo stone. Let's try it out. Save the whole thing. Jump into the arrangement. Then I'll consider what's been said here. Remove the clutter around the shaded objects. And then we'll re-examine the statistics. Once I take that completely out, that wouldn't be built anyway. Important, you are now seeing a very, very interesting topic here, and that is a novelty. I have in my possession a solitary module. It used to be a hat, specifically an east-west hat, that I had the ability to choose from. Now we have individual caps here. I can remove this one, then it's gone, and the individual caps stay in place. That means the wind deflector light is then attached at the back here. This means that the wind deflector plate is directly attached at the back. Let's show it again very briefly. Here, the wind deflector plate is attached directly here, anchored here as well, screwed in place, and thus you can then also build a pure east hat or cap and no longer need to be part of the system. Let's look at the statics to see what happens. Maybe we're currently overloaded in terms of insulation. Of course, that can happen now. I'm curious. It'll take a bit of time now. We have more on the roof now. It's a bit rugged. The system has more to calculate. Still allowed? Need to mention at this point. As stated earlier, system will promptly appear in Solar.Pro.Tool. It will take a bit longer, about 2 weeks, and then the runtime speed will be back to normal here, so you can make progress quickly. Yes, much faster than planned. Interesting. You can see that the ballasting is now increasing here. The weight has increased by about 4 kilos towards the south system, where the east-west system is better suited in terms of ballast and aerodynamics. But what is the reason? Let us go directly in. Clearly, well, I simply require additional ballast here with these eastern caps, and in fact, it is the ideal focal point. You observe 2 ground shoes here, but I must choose 3 ground shoes here. Here is the intermediate piece with 225 or 400 something. I'm unsure what kind of intermediate piece is inside what I've selected. This is crucial for you now. Look, I placed the cone on top, have my wind body, 2 ballast angles underneath. Here I don't need any ballast, just put stones on rail. Alex, maximum loads on the modules are also displayed. Here you have the option to output point loads on the left, ballasting areas. You can output all possibilities and options. And here you have also specified the loads. It is also possible to include the loads here. Now as we zoom in here, we can see the point loads on the individual shoes again. Pretty cool, I must say, design-wise. As mentioned, not entirely final. Now let's move on. 3 ground shoes everywhere, also needed. At the back, ballast increases naturally, but nicely. No immediate need for ballast tray or ballast angle, but we have the chance to optimize the ground shoe technically here once more. I like that. Stones are present on the rail. Here again. Then, there is a small mistake, but it can be forgiven for now. Yes, we could design the whole thing now. I'll go back to the construction once again, saying here, no, I don't know which roof. I want the large ground thrust. Make the system complete for me, cost whatever it may. That's naturally the approach behind it all. Approach behind the entire concept that everything can be constructed here. I will return to this location once more and simply remove a small element to enhance the loading speed. And then we will see that in this part now everything will be covered with ground shoes. Whatever can be covered. And of course that is essential. Let's not kid ourselves. How many roofs are there with soft insulation, with 3 layers of bitumen on top, where you don't know what has happened there? Duration of building existence? Still to be determined. Insulation type? You have no chance. 0 risk. Max ground shoes. We're safe. Thus matter settled. Structural side loaded. I'll show them promptly. It's obviously work, that's for sure. Attaching the ground shoes there quickly remains almost, because if you can't build a system here, then you didn't get the job. Therefore, the ideal solution and the ideal answer to construct flat roofs on a large scale, rapidly, with utmost leverage, particularly at the back for ballasting. In summary, Fast Flat is very fast to install, with few components and minimal storage space, combined with the software and ground pressure, also suitable for Gen 1 and Gen 2. This means that soon you can also plan Gen 2 with ground pressure. A comprehensive software for planning. You see, in my opinion, it works faster for fastener than the previous generation too. Therefore, all paths are open. The only thing you need to do is plan, order, purchase, deliver, and build. I'd be happy to hear from you soon when we meet at Intersolar. If you have any questions, The chat is open for 5 more mins. You're welcome to join. I'd be happy. Thanks for your attention, for a great day, for the participants in the online seminars. Overwhelmed when we get encouragement or resonance, even though we train software and sell aluminum and steel. That's great, and I'm happy about the participants. I say thank you, take care, stay healthy, see you soon, bye, cheers.